Good morning, sunshines. It is Mrs. Duskevich, and I'm going to teach you a little bit more about stoichiometry, but we're going to take it a step further and do limiting and excess reagents. So don't freak out. It's just like if you're cooking in your kitchen or making your lunch. Let me give you an example. Mrs. D loves chips and pico or salsa. You guys, I got this stuff at Aldi. It's mango pico. Oh my gosh. But I'm telling you right now, it is mother of all hot. I did not realize I was taking a mouthful of jalapenos as well. It's like, whew. So good thing I had my water close by, but it was delicious. So anyway, let's say that 12 chips plus 6, whatever, pico, let's say ounces, okay, yields 1 happy Mrs. D. So I go to my cabinet and I find that I only have 10 chips. Will Mrs. D be happy? No, Mrs. D will not be happy. However, can I still have some chips and pico? Yes. Which will I have leftovers of? Chips or pico? I will have leftovers of pico because I only have 10 chips, but I have plenty of pico. Therefore, my limiting reagent is chips and my excess reagent is pico. So we're going to translate that into chemistry, of course, because that's just the way we roll, right? So here we go. So we're going to take copper nitrate. And so first, when copper 2 chloride reacts with sodium nitrate, copper 2 nitrate and sodium chloride are formed. So of course, we're going to write a balanced equation because that's what we do for stoichiometry. So we have copper 2 chloride, CuCl2, reacts with sodium nitrate, and they're both +1, -1. We're going to get copper 2 nitrate and sodium chloride. So let's make sure our equation is balanced. So it looks like our nitrate's not balanced, so we need to put a 2 over here to balance our nitrate. And then it looks like now we kind of screwed up our sodium. So we've got 2Na, 2Cl, 2Cl, 2Na. So there we are. We're in good shape. So what we want to do is first we have to think about some stoichiometry here. So if 15 grams of copper 2 chloride react with 20 grams of sodium nitrate, how much sodium chloride can be formed? So this is where we need to look at both of them because we want to see what exactly will be our limiting reagent. So what we're going to do is we're going to come down here and we're going to start with 15 grams of copper 2 chloride. And we are going to see that's going to be our have for one of our problems. 20 grams is going to be our have for another. And need is going to be sodium chloride for each of them. And when we say how much, like typically you would go with grams. If you want, you could do moles at this point when we're just determining the limiting reagent. So let's just go with moles at this point so we can identify what the limiting reagent actually is. So first thing we're going to do is we're going to go 15 grams of copper 2 chloride, and my molar mass of copper 2 chloride is about 133.5 grams. And that's for every 1 mole. Because remember, when all else fails, we don't know what to do, take it to moles because we use moles all the time. Now we're going to use our mole ratio because we want to go from copper 2 chloride to sodium chloride. So we go up here to our equation and notice we have basically a 1 with copper chloride and a 2 with sodium chloride. So our mole ratio for every 1 mole of copper chloride, 2 moles of sodium chloride are formed. So that is our mole ratio from our equation above. Now, if we were to solve right now, we are going to get our answer in moles of sodium chloride, and that is okay for right now because we can determine our limiting reagent just by using that. So we're going to get 0.225 moles of sodium chloride. And guys, at this point, I'm not super concerned about sig figs just because I want to compare one number to another, and sometimes those numbers can be really small and tricky, so it's okay to use 3 decimals there. So I'm going to go ahead and do then 20 grams of sodium nitrate. So I'm given 20 grams of sodium nitrate, and I'm going to find that my molar mass for sodium nitrate is 85 grams of sodium nitrate for every 1 mole So I get it into moles because I cannot do a mole ratio out of grams. So I always have to get it to moles first. Once I do that, I'm going to use my mole ratio. Notice I have 2 moles of NaNO3 for every 2 moles of NaCl. According to my mole ratio, I have a 2-to-2 ratio for every 2 moles of sodium chloride. So if I calculate that, I'm going to get 0.235 moles of sodium chloride. So here's what I want you to understand. If we have 15 grams of copper chloride, this is the number of moles that I can make of sodium chloride. But we also have 20 grams of sodium nitrate, and I can make more. However, I can't make 0.235 moles of sodium chloride because I do not have enough copper chloride. Therefore, that is why the one that can make the lowest amount is my limiting reagent. So in this case, copper 2 chloride is my limiting reagent. So again, my C here tells me what is my limiting reagent for this reaction. Copper 2 chloride is my limiting reagent. Therefore, that tells me that I can't make any more because I'm going to run out if I use all of my sodium nitrate. So then what I want to do is I want to think about, now my next question is, how many grams of copper 2 nitrate are formed? Well, this is something new. Now, once I determine my limiting reagent, I have to use that to calculate everything else. So I need to go back up and find out that I want to use this piece of information. Okay, I see this is my limiting reagent, and that comes from 15 grams of copper 2 chloride. So I'm going to use this 15 grams of copper 2 chloride to calculate everything else, because this is like my chips. I can only have 10 chips, so I can only make this much. So I come down here, and I'm sorry, I forgot that number, 15 grams. So I'm going to start with 15 grams of copper 2 chloride, and I'm just going to do a normal stoichiometry problem, this being my half, and grams of copper 2 nitrate as being my need. So I'm going to go ahead and convert here. So I'm going to go copper 2 chloride to moles. And so I have, again, here's my molar mass of copper 2 chloride for every 1 mole of copper 2 chloride. And I went ahead and brought over my balanced equation to this slide as well. So if I look at my equation, I have 1 mole of copper 2 chloride, and I have 1 mole of copper 2 nitrate. So I have a 1-to-1 ratio here. 1 mole of copper 2 chloride, 1 mole of copper nitrate. Copper 2 nitrate, sorry about that. Okay, but I want to know how many grams. So that's my prerogative right now. So I'm in moles of copper 2 nitrate, so I need to go ahead and calculate the number of grams. So I have 1 mole of copper 2 nitrate for every, and the molar mass of copper 2 nitrate is 187.5 grams. So I'm finally to the point where I can calculate. So I'm going to multiply 15 times 187.5 divided by 133.5, and I'm going to get 21.07 grams of copper 2 nitrate. What this is saying is, if I only have 15 grams of copper 2 chloride, then I can only make so much because this is my excess. Sodium nitrate is my excess reagent. So I'm going to have leftover of this. This is my limiting here. So this copper 2 chloride is going to limit the amount of copper 2 nitrate and sodium chloride produced, and it's going to limit this to only produce 21.07 grams. So I go on to the next problem, and I want to say how much then excess reagent is left over. And this is where, like, you just got to follow your numbers and you got to think logically here. Okay. Now, first off, we know that this is our excess. What we want to find out is how much excess that we have. And so what we're going to do is we're going to take from our problem from above, And we're going to say, okay, if we have, let's go back to this wonderful number here, 15 grams of copper 2 chloride. That's our limiting reagent, and that's how much we have. So we have to base everything else on that 15 grams of copper 2 chloride. So we're going to say if we have 15 grams of copper 2 chloride, then how much do we need of this? So our have is grams of copper 2 chloride, and our need here is grams of NaNO3 because we want to compare how much we really need. So what we have here is 15 grams. And again, we're going to do what we've been doing. 135 grams of copper 2 chloride for every 1 mole of copper 2 chloride. We're going to do our mole ratio. So we look at above, we have 1 mole of copper 2 chloride for every 2 moles of NaNO3. So you have 2 moles of sodium nitrate. Okay, so let's see what we can cancel so far. Now we're at moles of sodium nitrate. I want to go ahead and calculate the number of grams of sodium nitrate. So we're going to go 1 mole for every molar mass, which is 85 grams of sodium nitrate. And so we're going to take 15 times 2 times 85 divided by 133.5, and we're going to get 19.1 grams of sodium nitrate. This is the amount needed. This is what's needed to react with 15 grams of copper 2 chloride. Because remember, all we have is 15 grams of copper 2 chloride. Now, what we have to consider, though, is that from above, okay, we're going to go back and we have 20 grams of sodium nitrate. So we have 20 grams. So all we're going to do is this is how much grams we have. This is how much we need. So we have 0.9 grams of sodium nitrate left over. This is left over in excess. Okay, so this is how much we have left over. Not a lot, really great. We're not wasting a whole lot. All right, last point of this problem. So now we have to look. If 11.3 grams of sodium chloride are formed in the reaction described in problem 1A, what is the percent yield of this reaction? So we are going to go back to the reaction. We have 11.3 grams of sodium chloride. Okay, so 11.3 grams of sodium chloride are formed. This right here is called our actual yield. This is our actual yield. So this is, if I went up to the lab and I did this experiment and I dried this and I weighed it, my sodium chloride would be 11.3 grams. You guys, the likelihood of my actual yield being close to what I calculated is not great. Okay, so what I want to compare this to is my theoretical yield. And your theoretical yield is calculated through stoichiometry. So all of this stuff we're calculating is our theoretical yield. In theory, this is what you should get. Then you go and do the lab, and there's always sources of error. Something comes up, something doesn't dry right, something doesn't all come out of solution. There's lots of things. So therefore, we have to compare it to our actual yield. So we need to figure out our theoretical yield. So we come back up here, and I want to look so we don't have to do more problems. When we have 15 grams of copper 2 chloride, remember we want to base everything on our limiting reagent, we are able to form 0.225 moles of sodium chloride. So we're going to take that 0.225 moles, go back to our problem, and we're going to say, okay, when we have 0.225 moles of sodium chloride, how many grams are actually formed or theoretically formed? And through stoichiometry. So here's our molar mass. Okay, and then we calculate. So we take 0.225 times 58.5 grams, and we get 13.2 grams of NaCl. This was our theoretical yield. So based on our stoichiometry calculations, this is what we'd like to get. But we didn't. We got 11.3 grams. To find the percent yield, what we do is we take our actual yield divided by our theoretical yield. So we take 11.3 grams divided by 13.2 grams times 100. Think of it this way. If I was grading your assignment, you should have gotten 13.2 points, but you got 11.3 points. So when I put your number on top of your paper, I put what you actually got over what you should have gotten. And then you find your percentage. It's the same thing here. So if I take 11.3 divided by 13.2 times 100, I have an 85.6% yield. So that means when I do this reaction, I'm going to get 85% of the product of what I should get. And this is an amazing percent yield. There's some percent yields out there that's great if you get like a 65% yield. So I know there's a lot of problems with this. I'm going to give you guys, there's a lot. I'm going to give you a few more of these, like where they build upon each other. But this is problem number 1 on your limiting reagent worksheet. And we're going to use this in lab as soon as I can get you back into school. Okay? So ask me questions. You guys got this. Just do your best, and I will answer any questions I can. Take care, you guys. Bye-bye.